Again, good morning, everyone, and a very happy Sunday to you all. I hope you're doing well and ready for an exciting session. Today, let's just not listen, let's have the energy high by interacting. Please ask questions, are always welcome. I'm Anusha, the TA lead of Semicon Technolabs. It's my absolute pleasure to welcome each one of you to this demo session on design verification. We at Semicon Technolabs are excited to have you with us. We are confident that today's session will be very insightful and inspiring and valuable for everyone. We have a special honor to have Mr. Umar Farooq, the senior most director for the design verification team at Radiant Semiconductor with us today. Also, we have Tasleen, our HR executive. She's been coordinating with us for all the training programs. So she'll be your single point of contact for any queries related to Semicon Technolabs. Once again, a very big warm welcome to everyone. Before we start, let me quickly share the purpose of today's demos class. Our aim is to give you a solid introduction to design verification, a vital pillar in electronic engineering, and also to walk through our comprehensive training program, which includes engaging theoretical session, hands-on practical labs, real-world project, and a strong job placement assistant. I would like to emphasize again, it's a job placement assistant in our integral part of our program. Coming to who we are, Semicon Technolabs is established in the year 2016 with its headquarters in Bangalore and operational as well as in Hyderabad. We are both operational in Bangalore and Hyderabad. We have a team of highly qualified instructor with 18 plus years of combined experience who are very well versed and working with the top product companies. All the trainers are carefully selected to ensure the highest quality of the training program, bringing to the table a very expertise and knowledge. So you see, we are the leading providers of internship and training programs in design verification, physical design, analog layout, design for testability, analog circuit design. As of now, we will be starting our new batch of design verification training program from the mid of May. To ensure best outcomes to the students, day-wise assessments are given. A test will be conducted after completion of each module. And also grand tests are conducted after completion of half syllabus. At the end of training program as well, you'll be having your test. Mock interviews are conducted in a timely manner to assist the students to face the real-time interviews. We also provide career guidance for your preparation of resumes, also your resume preparation for your interviews with the various organization as well as recruiters. At Semicon, we take an immense pride in our 100% placement assistant record. Our graduates have successfully found rewarding position with prestigious companies such as Qualcomm, Intel, AMD, Samsung, Google, Radiant, and many other companies. Since our establishment, we have successfully placed and are proud about, we have placed almost over 550 students with our collaboration and product as well as service. To see about what is semiconductor market, as you begin your career in semiconductor industry, it's important to understand the incredible impact this sector has. Semiconductors are the backbone of modern technology, driving assessment in industries like electronic, automotive, and healthcare. For instance, the global market is closely tied to semiconductors growing rapidly from 2.5 billion in 2032 to project 9.57 billion by 2032, which is an impressive annual growth rate of 19%. This growth is fueled by the rising demand for high performance chips in devices like smartphones, smart TV, supporting technologies like AI, IoT, and the metaverse. The automotive sector is also booming with semiconductor, enabling innovations in electronic vehicles, autonomous driving, and advanced safety systems. This trend clearly highlights the exciting opportunities and the immense potential that lie ahead for you in this dynamic and ever evolving industries. You see, these are the few advantages of VLSI technologies. VLSI technology significance the overall size of circuit. It increases the cost effectiveness of electric devices by integrating more functions onto a single chip. It makes circuit work faster. It uses less power than using a separate part. It makes device more reliable. It saves space and helps to make things smaller. So, coming to our eligibility criteria, we want someone from the engineering background with 60% of academic aggregate. The course duration might be from 3 to 4 months, and a program ensures in-depth understanding of the subject matter and are very well prepared for reaching your career goals. Offline classes will be conducted in a Bangalore center from 9 to 1. So we have corporate courses, that is nothing but, as I mentioned in the beginning, the courses will be ASIC design verification, design for testability, physical design, analog circuit design, and analog layout. So these are the modules. You'll be having 5 modules. So the tools used will be Synopsys or Cadence. As I mentioned, it's going to be 4 months of duration. So EDA partners that I mentioned, it's Synopsys or Cadence. So let us see some of our students what they say about Semicon. So these are the few Google feedbacks. And here are a few placement histories at the companies where they've got placed. Mr. Ajay Krishna was placed in Radiant Semiconductor. Sai Sudupti was placed in Radiant. Hemanta was placed in Radiant. And Venkatarama Reddy was placed in Radiant. Here is an email ID as well as a website link. Our locations are in Bangalore as well as in Hyderabad. We are at the end of the slide. I'm so grateful and honored to introduce our esteemed trainer for the session, Mr. Umar Farooq, who's a postgraduate in VLSI with 15 plus years of experience in design verification, started his journey as a professor and worked as a professor for 2 years. And later, he started his journey into corporate sectors as a design verification engineer, worked with clients such as Samsung, Microchip, and HCL. His passion for teaching and commitment to students' success makes him the ideal mentor for this demo session. For the upcoming design verification training session. During this session, you'll have this opportunity to learn about the fundamentals of DV modules covered in our training program, as well as you can ask questions and clarify any of your doubts. We encourage you to actively participate and make the most of this unique learning. Without any further delay, let's begin our demo session. I request every one of you to join me in welcoming our speaker for the day, Mr. Umar Farooq, to start the session.
Good morning, everyone. So let me share my screen. So let me know once you guys are able to see my screen. Uh, Thank you so much, Anusha, for my introduction. Yeah, I just want to give some more brief about myself, guys. My name is Umar Farooq Sheikh, and my role is currently I'm heading a team at one of the VLSI company as a director for the design verification. And as she mentioned, I have totally 15 plus years of experience into ASIC verification at front end side. And my experience mostly into a top three the world companies in semiconductors. Those are the Samsung, Qualcomm, Intel. Apart from that, I do have an experience into microchip and so on. So what my expertise lies into. So I got a chance to work on the IP and SoC functional verification and GLS verification as well as the low power verification. So that's where the different opportunities we may get as a the verification engineers. And this is my LinkedIn profile. Yeah, you can go and look at it to understand more about me. So, coming to the agenda. So, today, this is the agenda we will be going to discuss in today's session. So, we will try to understand what is VLSI and why there is a huge demand for VLSI and what exactly the different flows we follow in VLSI, like what is ASIC and what is FPGA, and what are the opportunities for the ASIC and what are the opportunities for FPGA, and how the design flows for each of these and what is the design verification, what kind of how the verification matters if it is in ASIC and if it is in FPGA, how it matters, and why we need to choose the design verification, and what is great about it. Because as a DB engineer, I feel myself is working as a DB engineer. I feel like great about it, but yes, I just want to the share what is great about it and who can choose the DV. And I mean, the person who has the kind of capabilities, who has, they can go for the DV. And then the eighth point is like the opportunities of DV. What kind of opportunities we have, and what is a course curriculum, and why we have built the course curriculum in such a way so that we can meet the current market demand. So, what is VLSI? So, as everyone knows that because everyone are from the graduation and you guys, most of you would be having a subject called VLSI or something you would have heard about the VLSI. That is nothing but very large scale integration. Basically, we are doing an integration in a very large scale manner. What is that integration? Basically, we are doing it. So we are doing a transistor. A transistor is nothing but a basic building block in VLSI or a semiconductor. Let's take an example of you take if you are constructing a home and the basic building block of the home is a brick. And similar to here, for a chip, for a semiconductor device, the chip is a heart, and then inside the chip, the basic building block is a transistor. So basically, what are we doing in VLSI? So we are integrating millions and billions of transistors to achieve an object, sorry, achieve an application, to achieve a goal, basically. So that is all about the VLSI. So what we do, basically, what is the output of it? Once we integrate the millions of transistor, what kind of outputs we can see in real world? So those are the processors, the memories, SOCs, and so on. So the processor. So in today's world, you take any electronic gadget, you might be having a processor if it is a complex system, and if it is a less complex system, you would be having a microcontroller, a small controller, which would be sufficient enough. We take an example of a laptop. Yes, without processor, you can't assume a laptop. And without, you take an example of a robot. Without processor, you can't assume a robot. And you take some small applications like TV application. It could be a washing machine. It could be a small refrigerator, and it could be a small ACs. So there you don't need a complex processor, but yeah, you need a small microcontroller which can take up your other small activities there. So basically, these are the different, the real world components which we can see, and those are all coming from now the VLSI technology. So yes, as I mentioning the VLSI, yes, VLSI is used to create a tiny and powerful chips which can be used for the different applications. So nowadays we are seeing a smartphone, the smartphones, computers, you take car. No, nowadays there are so many cars are coming up with the ADAS features and which are fully equipped with the VLSI chips. So I mean, basically it helps a driver to drive it and for his safety and properly. I mean, it facilitating the car to drive it properly, basically or even complex roads like in India, you can take about, you can talk about, yeah. And before we let's understand some more about the history of it, basically, how the VLSI has come. In 1950s and 60s, I mean, the humans have invented technology that is a small scale integration where the tens of the transistors was there and the application areas were like calculators and military systems. And later in 1970s, the invention has grown up, and then we got the medium and large scale integrations where we had hundreds of transistors and to perform as CPU and memory chips, and those are not complex CPUs. Small addition, small subtraction, only these kind of things we used to take, we used to consider, and that is all about the MSI and LSI and small memory chips we used to have in 1970s. And one of it was like Intel 4004 series, which has a 2300 transistors, which was the first commercial processor in 1971 was invented. Late 1970, that's where actually the VLSA has started and it is still going. So basically in 1970s, late 1970s and 1980s, yes, there was some 10,000 plus transistors we had and we were doing some CMOS technologies, like I mean some EDA tools and semiconductor manufacturing. I think at least the R&Ds have started late 1970s and 1980s. And as you know, we were studying in our the academics. It was 8085 or 8086 processors. So you just think of it like when was this process have got invented? In 1970s, late 1970s and 80s, the 8086 processors have invented, and still we are studying the same in our academics. That's where the industry and the academic gap is. And where are we standing as on today? So we are somewhere around 2024, 2025. The VLSA has started some 1970 to 1918, but where are we standing with respect to the transistor count 2024 and 2025. So these are the different types of applications we have, different type of chips we have, and with respect to the transistor count. So Apple M1, a MacBook, which has a 16 billion transistors as in today. 2022, Apple has come up with M2 and M3 subsequently, which has 25 billions. And 2022, NVIDIA has come up with a one GPU, which is 80 billion transistor. And later in 2023, AMD has come up with one more chip, which is of 153 billions. And Intel also come up with Intel Meter Lake, which is 2020 in the year 2023, which is of 100 billion transistor. But there is a company called Cerebras, and which has come up with 850 billion transistors, which is the largest ever as on today. And this AI chip is used to train the AI models and scientific applications. So Cerebra is a US based company, Cerebras, and who has come up with this as the largest ever chip till today. And why there is a demand for VLSI? So we might be, I mean, basically the gap between the academic and then the real world is we don't have a much awareness on VLSI. Why there is a demand basically? Why there is a boom is coming in India, and everybody is talking about it in India, and everyone outside India also talking about it. There are countries who are looking for the leadership roles. Basically, why? Why is this? So let's talk about India because as our focus and our market is purely in India, let's talk about some what happened in India. What has happened? How the VLSI have introduced it in India. In 1980s, there was some early foundations happened. Like our DRDO and our ISRO have started doing small research and small academic programs on the DRDO and ISRO. And later at some time, and we have established IITs and IIs ISC Bangalore. So 1980s, we have done this to come up with or to complete the VLSI or to start with the VLSI, basically early foundations. And in 1990s, the industry have entered into India. There were two companies called Texas Instrument and ST Micro, and these two are the two companies who have come to India and they have started doing some ASIC design and embedded system and DSP opportunities. Basically, they have started doing these chips. And 1985 was the exact time when the TA have started set up a design center in Bangalore. Even now, the design center of TI is there in Bangalore, and they are doing good. And 19 in 2000 era is where exactly the growth phase have come in India. So there are companies like Indian-based companies. You can talk about like a Wipro, HCL, TCS, Infosys. All these top companies have started contributing to the VLSI technology with respect to the verification side, full chip design side, and EDA tool development side. So we call these companies as a fabless companies because we don't have any fabs. Basically, these companies doesn't have any fabs. They don't have any fabs. So in 2010, 20 to till today, we are into an expansion, and our national focus is on onto this basically. So what are we doing it actually? So there are so many startups and so many product companies have come to India, and they are doing a lot of R&Ds with respect to a fabulous designs, with respect to with respect to a fab. Basically, a Micron, which is a US based company, they have come in and then they have started a fab in India. They are already working on it, and the production have not come. But yes, something is going on the fab side as well. So not only that, there are some government initiatives also have done to boost the upcoming the resource need basically. So Indian government has come up with a lot of the programs to boost our VLSI sector. So overall in India, right, 20% of world chip design talent stays in India, and they are majorly working for a different product companies like Intel, AMD, Qualcomm, Nvidia, along with the service companies like the Wipro, HCL, TCS, Techem, and Infosys. These are the top, like even as well as L&T. So market growth and demand. So in India, we are expecting to grow. Um, Basically, as on today, we are at some $52 billion we are into, and we are expecting by 2030 it will be doubled. So that is the expectation the Indian government also have, and basically which sectors we want to grow is automotive, telecommunication, and consumer electronics. So these are the three different sectors where we are expecting our Indian business can grow from 52 to $103 billion. So these are the automotive electronics, industrial electronics, and mobile and IT devices. So, as I told you, the government has come up with a different initiatives basically. So, Semicon India program, and then DLI scheme and PLI scheme. So, the main objective of these different programs is like we want to show ourselves are like Atmanirbhar Bharat. We want to prove ourselves. We want to increase our resource capacity. We want to increase our manufacturing capacity. Overall, we want to prove ourselves as a global leader in semiconductor because there are countries like US, Taiwan, China. They are already into it and they are already competing each of them. And then we want to be in one of the competitor list. So that is the reason government has come up with so many programs to bridge the gap between academics and then the demand of the resources and to meet the talent. So, as in how the workforce from 2014 to 2024 in a decade, how the workforce have increased. So, with the VLSI workforce in India. So, 2014, we were somewhere around 3,000 engineers. You think of it actually getting a job, getting entry into VLSI level is not so easy because If you talk about a software engineer, there are so many software opportunities and so many engineers, so much of competition, and then there are a lot many things are involved over there. So every day technology is coming up, new technology is coming up, and there are a lot of challenges we had there. But once you compare with them, they were into lakhs, they were into a crores maybe. So look at our VLSI workforce here. 2024, the number of VLSI engineers in India, it was 3,000. So in 2024, it was after 10 years, we were somewhere around 25,000. So now our target is 2,50,000 by 2030. So it's almost 10 times of it. But the problem is here we don't have a talent. That is because the people are not aware of it. What is what kind of the job opportunities will get it? They are not aware of it. That's the reason. See, I'm sure that by 2030 we may not able to meet this 2,50,000 the opportunities which we already in pipe to get it in pipeline to get that those many opportunities. If we don't grab this opportunity from India, yes, there will be other countries like Vietnam, Philippines. There will be other countries like some Europe countries, the Turkey and UAE. All these countries will grab this opportunity eventually if you don't grab this. So this is the entire VLSI engineers. So when I say entire the all together VLSI engineers, VLSI in VLSI again we have a different types of domains. That is like a design verification, and then physical design, physical verification. Analog side we have analog circuit design engineers, analog layout engineers. We have it all together as a VLSI engineer. So 20 by 2024 altogether we are like 25,000 now. And what about the design verification engineers in India? Because our interest is lies in design verification. As I am also from design verification, you guys have also joined to for the design verification. So if you see here, almost in 2014, it was 1,800 engineers we were having as a part of for the DV roles, design verification role. It's more than 50%. So here you see a 50%, here also a 50%, here also a 50%. So approximately you see till 24, we were somewhere around 50%. So the opportunities for the design verification engineers in India is almost 50% if you compare all other domains of the VLSI. So in 24, it was almost like a 45%. You see the history of it. History says that we are more than 50%. Sometimes we are equal to 50%. We are less than 50%. But we are somewhere around 50% always. So these are the opportunities we have in India for the design and verification engineer. So, so let's look at now pure technical things. What is an ASIC and what is an FPG? So anybody have any question till now? I would like to answer if you guys have before I jump on to other topics. Okay. So let's go ahead with ASIC versus FPG. So the VLSI, the technology can be can brought up in two different ways. Basically, it could be an ASIC or it could be an FPGA. So there are two type of opportunities we have. One could be an ASIC engineer, one could be an FPGA verification engineer, or FPGA designer, FPGA physical design engineer. So whatever. So whatever the different the roles we have in VLSI, that could be for FPGA or that could be for ASIC. Let's understand what is ASIC and what is FPGA. So ASIC stands for, as we all know, Application Specific Integrated Circuit. It's basically a chip which is which has which built for a specific application. Let's say a case like I have brought up a chip and that is for the smartphone, and I have brought up a chip and that is for only for server, that is only for laptop, that's only for robot, that's only for satellite. So this chip cannot be reprogrammable. We can't reprogram this chip at all. This is for one specific purpose we have brought up, and that is for that specific purpose only. So what kind of applications we have for the ASIC? You take a smartphone, as I was talking, automotive systems, and then telecom equipment, consumer electronics like smart TVs, smart watches, washing machines, as well as we have a Bitcoin mining also. We have a different specific chips. We have application specific integrated chips that will be used only for that purpose. So, and how a typical ASIC architecture looks like. A typical architecture looks like. Basically, for any, let's say, if you are building ASIC chip, so what it contains? So it should contain a core logic. Basically, it could be example for encryption. Let's say if you take a TV application, what happened? There will be an encryption. Decryption has to happen. So how a TV quality, whatever the TV quality nowadays, you are seeing that FHD, UHD. You take a different types of the TVs, right? The broadcasting, whatever you get it from the antenna, whatever the Tata Sky you take or any other Geo fiber net you take or whatever the antenna you have it on top of your house, that will be a broadcast channel getting sending out a data via satellite, and then that receives it, and then it has a number of frames. Basically, let's say 60 frames per second, 50 frames per second. It is accepting that the number of frames, but how a quality image you are able to see that. So let's say you are seeing you're getting 60 frames per second video, you are getting it, and internally you have a chip in your TV. That chip, what it does, 60 frames per second data it takes, and it makes 120 frames per second data. So basically, it builds the frames in between so that the image frames in between, so that the clarity looks like a very good for you. So that's what is really happening in all FHD TVs, UHD TVs. So that's where that encryption and decryption comes into picture. So the core logic blocks, as I said, there will be a very important blocks and which can be a specific purpose. And we should have an ASIC can have a memories. It could be a RAM or ROM and IO pads and clock management, power management, and there are analog and mixed signal blocks. So let's talk about a real-time example. Let's take a laptop. So your laptop will have a core, your laptop will have memory, your laptop will have the USB basically. So USB is what? So how a USB is get connected to your laptop? There will, if you look at the USB, if you look at inside the USB, inside in the sense like just tilt it and see, you may see a physical pins are available. That physical pins, when you plug into your laptop, and there is already some physical pins are available at the laptop, and your USB is get connected to those physical pins. Then the physical connection established with your external USB device with your internal laptop board, basically RSOC. These two get connected. Now the data transfer happens. How? So this physical pins, whatever we have, right, that we call it as an IO pad. So these are the pads, input output pads. These pads which establish the connection between the external devices with the internal the circuitry. So we also have a clock management, power management. Yes, if you take a laptop, you don't use it. If you enable the hibernate, it automatically shuts off everything and it enters into a hibernate stage. That is something power management, intelligent power management. We should have it, which can eventually reduces your clocks also wherever the clock requirement is not there. And you can also have analog and mixed signal blocks. So like sensors, audio, RF. So wireless audio you have where you have the analog and mixed signal things comes into picture, and you also have a thumb basically. Most of your laptop will have a thumb locking facility or the image, your face recognition, like how we have the smartphones. So all these facilities can happen with your sensors, basically the RFs and audios. So these are the analog and mixed signal blocks we have to interact with your device basically. So a laptop chip is a ASIC chip which is specifically intended to work for your laptop application. So this is the same example. You take it here. This is one of the Intel's a system where it has a Intel processor, Tiger Lake processor it had, and LPDDR is one of the memory they have. There is a dual RJ45. So this is basically MDIM. So this is used for the Ethernet purpose. Ethernet is nothing but a LAN cable. So if you connect a LAN cable, that also again physically should get connected to your laptop. Then only a connection can be established, and you can browse internet, you can send data and receive data via internet. So that is also possible with this. And then you also have a SATA where you can put your hard disk there, and you also have the SMS I2C. You also have a audio bias. So there are a lot of, so these all are, you can see USBs, different types of USBs. You can see USB 2.0, 3.0. What is the difference between USB 2.1 and 3.1 is just a matter of speed, basically, and power. So we do have a level shifters, HDMI ports. So your laptop will have an HDMI port. Your laptop will have a power socket. Your laptop will have SD card slot. So your laptop will have audio jack. So your laptop will have a DP port. So all these are basically different types of the accesses are the features you can say your laptop can provide. So this is all about a second example. And then what is FPGA basically? So field programmable gate array. So the advantage of the FPGA over the ASICs is like it can be reprogrammed basically. So it's an integrated chip that can be programmed or reprogrammed by the user after manufacturing to perform the custom design digital logic functions basically. So what are the application areas basically? So before we do a bulk production for the ASICs, most of the companies will use the FPGA for prototyping, and those who are at the R&D level, right? So they will use the FPGAs for prototyping, and then high-speed signal processing. They will use it AI/ML acceleration, aerospace, defense systems, medical imaging, automotive. So for these are the different types of applications where the FPGAs are used. Basically, FPGAs are used where the reprogrammable is required. Reprogramming is required here. So there are majorly we have predominantly we have two different companies which are working on the FPGAs. One is a Xilinx. Earlier it was Xilinx. Now it got acquired by AMD, and there was a company called Altera, and it got acquired by Intel. So Xilinx has a different types of boards, Spartan series, Arctic series. They have a lot of series basically. Similar to Xilinx, Alter also has Cyclone and Aria series, different types of the boards they have, the FPGA boards they have where the people can start using it, and they have their own supporting tools also for that. So how an FPGA, how FPGA architecture looks like, what kind of components it has, like similar to the ASIC architecture, right? FPGA architecture, what and all it will have. So the basic building block of the FPGA is a configurable logic blocks. So these blocks can be used to basically whatever the functionality you want to achieve, you can configure these blocks to achieve this functionality. It could be an AND gate, OR gate, NOT gate, or anything. So it also has the interconnects basically, the wires connecting to the logic blocks. So you see an example here, a typical FPGA architecture here. These are the logic blocks, and the IOs have connected. There are some interconnections you have, and IOs are connected to it, and this is IOs basically. So for any device, if any device want to connect to an external world, they need input output pins basically, the physical pins. Without that, it can't able to connect the outside world. So clocking and control unit, you can configure this for synchronization timing purpose. So this is a typical architecture of FPGA where you have a logic blocks, interconnects, and then IOs you have. So this is how an FPGA architecture looks like, and this is, as I said, this is reprogrammable. So what is the difference between ASIC and FPGA? Where industry is heading basically, and where the industry is basically or you may say the opportunities are more compared to FPGA and ASIC. So the opportunities basically the more for ASIC compared to FPGA. So you see here the number of units and the total number of cost. If when the units are less, the number of chips, here the number of units means the number of chips basically. The number of chips are lesser, then if you want to go with ASIC, uh, it's a very huge cost for you. And if you want to go for a less number of chips, then you need to choose the FPGA. And basically, the most of the startups, those who are on the product side, take a company called Simo.ai, take a company called Antita.ai, take a company called InspireSemi.ai, Inspire Semi, and you take a lot of companies who are at a, you may say like these companies are the startup product companies. So these companies they prefer to go with FPGA than ASIC initially because the volume of the chip is lesser for them. So for them the cost becomes very less for them. So what happens eventually? So as the number of units increases in FPGA, the cost gets increased eventually. But when it comes to ASIC, let's say a company called as Samsung, and it knows that it want to do a flagship mobile S series, where we are somewhere around now S24, S25. So it want to do a bulk production, and it knows that without bulk production, it can't sustain, and it's such a big company, and it's already had a proven record of all S series phones, basically a flagship phones, and so it choose to go with ASIC. It will not choose to go with FPGA. But the other way is like startups where they want to prove themselves as like their product. They want to prove their product before they go for a bulk production. Then they prefer FPGAs. So why I said the opportunities will be more for ASIC because as I said, the bigger companies will have a bigger projects or more projects and more opportunities will be there. So eventually you will get a lot of opportunities because of the bigger companies and bigger visions and more number of projects. Like companies called Samsung, Nvidia, Intel, Qualcomm, ARM, AMD, all these companies. As I said, the small companies examples also I took it. So apart from these, what else are the differences between FPGA and ASIC? So upfront cost, as we discussed, the lower in FPGA but higher at ASIC side. Time to market is faster in FPGA. We will talk about why it is faster, and time to market for ASIC is slower. And performance is moderate in FPGA, but performance is good at ASIC. And power efficiency is moderate at FPGA but good at ASIC. And design flexibility is high at FPGA but low at ASIC because it doesn't support reprogramming. And production value volume low to medium is good for FPGA, and if production volume is high, ASIC is a good. And field update basically it's easy for FPGA and difficult for the ASIC. So to understand why this the time to market is slower for ASIC compared to FPGA. Let's discuss about the flows basically. How the design flows, VLSI design flow in ASIC and how design flow in FPGA. FPGA design cycle looks like this. So first, the specifications come up. There will be an architect sitting over there, and they are highly professional and highly experienced engineers, and who will be looking at the market, and they try to understand what kind of need the market have, and they'll be coming up with some specifications. So once it comes up, the design will happen, and then as soon as the design, this is basically a behavioral code and as a DV engineer, we will be doing this behavioral simulation until we prove this. Once this is proven, in parallel to our verification, the physical design team they start writing the constraints. Basically, these constraints are not the constraints of what we do right at the test bench level. These constraints something on basically on the flop level constraints and source to destination paths. So they have their own way to write the constraint. Physical design team write the constraints. After that, the synthesis will happen, and there will be a netlist file get created, and that netlist file again will be used by us to do a GLS simulation, gate level simulations to ensure the behavioral simulation, whatever the test bench we have created for the behavioral simulation, the same test bench is used to run the gate level simulation will be simply replacing the behavioral RTL code with the netlist. What got generated by synthesis, and we'll use the same test bench here to ensure the functionality has not broken. And if any change, we will be suggesting to modify the constraint. We'll be suggesting modify some design. Depends on the type of bug we identify at gate level. So this happens parallelly. After that, there is mapping will happen, place and route will happen. There will be a bit file get generated, and eventually we'll be dumping out this code to FPGA device. So this is the flow involved into FPGA, where the STA also comes into picture because after STA we have a timing netlist before netlist in the sense like the gates the timing before STA it was gates without timing. So these two we will be evaluating and we'll be keep suggesting designer if any change is required. We'll be suggesting PD engineer to update any constraint. Basically, so why do we need to do this verification? Basically, anyways, we are doing behavioral simulation or we are verifying the behavioral code here. Why do we need a functional simulation here? This functional simulation or the GLA simulation is required to ensure the constraints written by the physical design team are proper. So, because for PD, right, this is a very basic inputs. They need it. Without that, they can't come up with. They cannot come for the STA. They cannot come for synthesis. They can't do anything. So this GLS ensures your functionality has not broken even after the physical design team defines the constraints, and then you whatever the netlist code generated that is meeting the expectation of your behavioral simulation. Ensure that. So this is the FPGA flow, and then now coming back to the ASIC flow, this is the ASIC flow. Here also we follow the same, the specification, architecture design, first the design architecture will happen. After that, coding will happen, RTL coding, and here people might be using Verilog or System Verilog. Nowadays, most of the designers they are using System Verilog code, which is synthesizable, and they should not use a code which is not synthesizable because eventually whatever the code they write it that should get converted to netlist. After that, we have an RTL verification. This is where our role comes into. After that, we have a synthesis, we have a DFT, for planning, placement, CTS, routing, a lot of process, sign off. So till here, till sign off, the work will happen in India. After this, for major ASICs, like a companies called AMD, Intel, Samsung, IRM, Nvidia, till this phase, the work will happen. After that, the fabrication, packing and testing, the chip, everything will happen outside India because we don't have a lowest technology fabs. We have the fabs now, and there are some fabs are also coming up in India, but those are not the lower nanometer, lowest technology. That is at a higher level, which is a 28 nanometer, which is 40 nanometer, 120, 180 nanometer, 90 nanometer. So, but not on a lower side. So, lower fabs are there outside India, like you say a TSMC, like you say a Samsung foundries, like you say the Intel foundries. So, these are the three major fabs we have outside India, and most of our the high complex ASICs where the lower technology have been used, those gets fabricated in these fabs. So this will happen. So this entire process for a new chip, it takes almost like a minimum to minimum 2 years. It will take 2 years entire process from spec to a chip. Again, once the this chip will come to a lab again. This has to be tested. Once this testing is done, then a bulk production will happen for ASIC. So this entire process will take minimum 2 years. Sometimes depends on the challenges we have. When we are going through this process, it may go for 3 years also. Sometimes it may go for 4 years also. We never know that. So, but in FPGA, it's always a 50% of time. Let's say it is for 2 years for a chip, and the same chip in FPGA takes 1 year for that. But the challenge is here. The process is different here. You don't have DFT, you don't have floor plan. You have a floor plan in place and dot, but not the level what we do here. And CTS, sign off, and placement, you have all of it, but not the level the way we do it at the PD side. Okay. So, any questions here? Anybody have any question? Okay. So I'll be moving on to the next one. So, how a design verification matters to with respect to ASIC and with respect to FPGA? How it matters? How it varies? So, which one to learn? But as I told you, the opportunities are more for ASIC, but there are opportunities for FPGA as well. So, how it matters basically? How we do a verification in ASIC? How we do a verification in FPGA? So, in fact, the verification is same for ASIC and FPGA, except the tools we use for FPGA, the tools we use for ASIC. Okay, so these are the steps involved in verification process. What we do basically, we will do a test bench development, we'll do a simulation and verification, we'll do a test plan creation, regression, formal verification, coverage, and debugging the issues and reporting it, collaborating with the design team, collaborating with the architects, and we do a generated report. So these are the steps basically involved. It could be either ASIC or it could be either FPGA. But the only difference is the tools we use it basically. And so if it is of FPGA, we do use simulators called Mentor Questasim. Now we are calling it as a Siemens Questasim. And this is a Vivado simulator and very later simulators. These are the simulators we'll be using for FPGA. When it comes to the ASIC, we are using the Synopsys, Cadence, and Mentor Questasim. These are the tools we are using it. Coming to the languages, yes, we are using the Verilog, System Verilog UVM here in ASICs because these are the complex chips. Considering the advantages of System Verilog UVM methodologies, we'll be using the System Verilog UVM. But yes, there are some ASICs which have Verilog legacy ASICs. You say they still have Verilog language as well here. And the boards, basically here FPGA, we have a different types of boards, Arctics board and Cyclone board, Zinc boards, and we have different types of boards we have, but for ASIC, we don't need any board. And debuggers and debugging tool, for FPGA, we have a different types of debuggers, GTK and Vivado analyzers, Signal Tap, and ILA. So these are the different types of debuggers we have for FPGA. But for ASIC, we have a DVE, GTK WADI. Again, this is from Synopsys and Signal Tab we have. And here we have a coverage tool called Mentor Questasim. But here we have a SimVision, VCS coverage, incisive metrics. SimVision is from Cadence, VCS coverage is from Synopsys, and incisive coverage is from Cadence. So these are the different tools, languages, boards, debuggers, and debugging tools, coverage tools we use when it comes to FPGA and ASIC. Why to choose the design verification? So out of all, why? What is the? Um, let's say if someone asks you, why do you choose the design verification? So the answer could be this basically, or what is the advantages basically we have as a DV engineer, or once we get trained into DV verification. So as I discussed previously, there is a high demand and there are abundant opportunities. As I said, 50%, approximately the 50% VLSI opportunities, they will come from or they will come to DV. They will come to DV, design verification. And also there are some strong foundation in VLSI concepts. We need to know, or we would be knowing it, how gates works, how mux works, how adders works, how decoders works, how encoders works, how counters works, how FSM works. So these are all very basic concepts, and we will be getting a very good foundation on it because we will be interacting with designers. We will be looking at the design code. We'll be verifying the design code. We'll be debugging it. So we keep getting refreshed on these concepts. and different protocol knowledge, basically. So, why I say a different protocol knowledge? You might be curious to know how a robot works. You might have a curious to know how a USB works, how an audio works, how a camera works in your laptop, how your fingerprint works, how an image sensor is working, how your HDMI is working. So you might be interested because these are all the real world components, and you might be interested basically to know how they are working basically. So you will get a feel of, okay, these are my real world components, and how they actually work, and I'm also part of that. You can get a feel of it basically. Like, I mean, if you're a PD engineer, you will never know what is application, how it works, and where it is used, where the board goes. You never know all this information there. But when it comes to the verification, you will be exposed to the complete architecture, application. You will be exposed to how it works and what complexities lies in. So day by day, we are getting a different protocols, complex protocols, depends on different needs, and we'll be learning to different protocols. That is one of the good exposure you have it here, because a career is not something like which you will be starting it today and you will be closing it after 5 years. No, and we are going to build a career that lays for at least 15, 20 years from now, and you should enjoy it while doing it. It is not something like, okay, some legacy job which you are doing it every day and you are getting more of it. Let's take an example of some jobs like the banking sector job, and some jobs like a teaching sector job. Let's say if you're working as a professor and you'll be doing it the same subjects, you'll be handling the same subject for years, and you'll get bored of it at one day. And let's say if you want to change the subjects also, how many subjects will change? And you will never get exposed to more subjects. Even though if you get more exposed to the more subject, maybe within 5 years you'll get bored of it, right? You'll get bored. And similar to a banking sector job, you will also get bored. Every day you are doing same thing, every day you are doing same thing. But here it is not something like that. Today you will be working for USB for about a year. After that, you will be working for HDMI, you will be working for PCI, you will be working for a robotized chip, you will be working for cryptographic chip, you will be working for modem chip, you will be working for laptop chip, you will be working for satellite chip. So there are, as the technology is evolving, there are different types of applications are coming up. Nowadays, we are doing on AI chips also. So as the technology is growing, and you'll get exposed to a multiple basically applications where you will enjoy the working, and that basically motivates you to stay in the industry and enjoy the work day by day. So it's about that, and who can choose the design verification? And these are the candidates basically who can choose who good at digital design concept, who get good at programming skills basically, and who good at program problem solving and analytical skills, and communication and collaboration. This is very important. The candidate should have good communication and collaboration, because the reason is we will be interacting with the designers, we will be interacting with an architect. Sometimes you need to propose, or you need to prove yourself, whatever the architecture defined architecture has problems. You need to prove that, and you should go and defend yourself, or you should go and talk in a bigger forum where you need to prove this. Eventually, architect has to understand that yes, he should go and modify the architecture. Uh, the same case happens with the designer also. So, and one more thing is why we need, there is one more reason why we need to have a good communication and collaboration. The reason is most of our architects are the seniors compared to us, and designers also seniors to us, basically. Let's take a case where where you are bringing up a new chip. So for that you need, let's say, a 50 people team you need, out of which 20 people, at least 20-25 people are required for your the overall front end side. In that you say five people will be designers, 20 people will be a design verification engineers. So these five people are the senior people, and remaining 20 people are the junior people. Junior people in the sense like the opportunities for the design verification engineer as a fresher, it is easy. Basically, you can't see. Let's say if you get trained into a design side, it is very difficult to get a opportunity as a fresher. It is very difficult. But as a DV engineer, if you are a fresher, and it is very easy to get an opportunity. And the challenging part lies with you is you need to have a good communication collaboration because you are a junior and you are working with seniors like architect, you are working with designers, they are seniors to you, and you should able to communicate the things properly when you see any issue in the design. That is important. So who should good at communication and collaboration? Yes, they have to choose this and willing to learn, willingness to learn. So these are the different, the five qualities are the five different qualities everyone should have. Then only it will be easy for them to enter into design verification. Engineer, once you are done with your design verification course, what are the different types of opportunities you have basically here? So these are the different opportunities you have. It could be you may be given opportunity to work for the IP, which is an intellectual property, or SOC. You will be given as a functional verification in that, formal verification, low power verification, power performance verification, VIP development, coverage driven verification, assertion based verification, GLS verification. So all these activities will be done by a DV engineer, design verification engineer. So company to company, time to time, project to project, you may get all these opportunities. But the major opportunities lies with the functional verification. And that too, it could be IP or it could be SOC. So as a DV engineer, if you want to get exposure to all DV concept, then at least you should work at one IP development, one IP test bench. So once you get a chance to work on one IP test bench development, then you can say you'll be exposed to a full complete DV. Like I mean, it could be a coverage, it could be a test writing, it could be test bench development, test bench architecture, it could be assertion, it could be anything. So you will get exposure to all different verification techniques, and you will apply them on your IP, and then that basically makes you strong at functional verification. Compared to all these opportunities of as a DV engineer, you will be having more opportunities on functional verification, basically. So these are the salaries, basically design verification engineer salaries in India. So these are the entry level salaries you have 0 to 1 year average salaries from 3 to 5. You have it depends on the region you are. Let's say if you're in Bangalore, if you're in Hyderabad, the salaries will vary. Noida, Pune, Chennai, wherever you stay, depends on the region, the salary will vary. Early careers, 1 to 4 years, this is the average salary range you have. And mid career, senior level, you have a different salary range you have. Coming to the opportunities, basically. See, key hiring locations. Basically, these are the five different metro cities where the VLS engineers have opportunities. In Bangalore, where the primary hub, where you have, as on today, this is a LinkedIn data. As on today, 19,000 listings are the 19,000 opportunities you have in Bangalore for VLS engineers as on today. Hyderabad has it's like almost like 50% of it what Bangalore has, and here this is like almost 50%. Pune is 5,900, Chennai is 5,700, Noida is 2,700. So these are the different key hirings at this moment, which are live in LinkedIn. So, keeping all these points, we brought up our design verification course curriculum because we know that if a, engi- if a, per- if a as a fresher, if a person go through the ASIC IP verification, then he can get exposure to the complete verification, design verification, where he can go and work on SOC, or where he can go and work on low power, where he can go work on VIP. So these are all will be easy once you know this point, once you know this basically. So, and as I said, once you have done IP functional verification, you can easily handle other things. So that's where our focus goes, and we have brought up our curriculum aligned to this point. So this is our curriculum. Basically, we have a different modules here. So module one, which where we are introducing the VLSI, what kind of applications of VLSI, process, scope, introduction, and then maybe after that we will be starting with the digital system design, basically where because I know that you guys have gone through would have gone through this digital system design in your academics, but still we want to brush up because everything the subsequent modules like Verilog system, Verilog UVM, they will be depending on this, and we should be very confident on this concept. When there should be then only it is very easy to debug once it comes to a real time project. So digital design test. After that, we have a Linux or Unix introduction because all our tools, whatever the tools we are providing, that will be on a Linux environment, and the same environment is used at every company. Like it could be you take any product company or you take any service company like HCL, L&T, you take Wipro, TCS, Infosys, you take any company which uses the Linux platform to use your to bring up your project, as well as the product companies like the top companies, Samsung, Intel, Qualcomm, all these companies. Every company, it could be a startup, it could be an MNC, they will be using the or they are using the Linux platform where they can bring up their projects. So this it is very important to know the Linux, the commands, the Linux introduction, where we also build our tool on Linux, where you can get a real time feel or whatever the practice you do on our tools. It's same as the same tool being used at the customer side or different the company side, where it is very easy to cope up the things there. So similar to very after this we have a module 3 called Verilog. We have all these the basically the different types of modeling, how we built all the circuits what we have gone through. It could be a sequential combinational circuits, and how we are building those circuits using the Verilog. After that we have Verilog test, and then lab we have where we will be bringing up a test bench on Verilog, because let's say if you want to enter into an FPGA, you sometimes you might need to bring up a test case in Verilog, not on system Verilog. Let's say customer has given a provision, or they had asked you to make a test bench on Verilog, then you should know how to do that. That also will be doing it here in this lab. You will be doing a Verilog test bench to verify the components or the RTLs being written on Verilog. And system Verilog, system Verilog, these are the different types of concepts we'll be going to cover in system Verilog, and followed by a test and followed by a lab. This lab focuses how to build a test bench using system Verilog on a system Verilog design or a Verilog design. After that, we have a UVM, which is a methodology, and these are the concepts which we cover in methodology with an example. And post that, there will be a UVM test, and then complex lab will be going to do, which gives you exposure of how an IP can be verified using UVM, so that you will be very good at all design concepts what you have learned or what you will be going to learn in our organization, and that will be like which fetches or which fetches you the other the DV opportunities as well, apart from the functional the IP opportunities. Suppose that we'll have a mock interview by industry experts. We'll be having your trainers will take some mock interviews. Post that we'll be calling the real world or the industry expert who are available and who are currently working in the industry, and they'll be taking you some mock interviews to assess you where are you standing. Post that we'll have a resume preparation, and then we'll be doing a placement assistance for you. So this is a course curriculum, and you can get the same course curriculum in our website as well. Any questions here? Anybody have any questions?
Hello, sir.
Yeah. Hi.
Sir, so what is the difference between a Verilog and system Verilog?
Okay. So system. So in Verilog test benches were the legacy test benches, and it does not have the concepts called the OOPS concepts. And you see here, there are the OOPS concepts are there. There is no concept called interface. There is no concept called explicit coverage concept. We don't have, and assertion concepts we don't have. Basically, you can consider this way: Verilog was a legacy language which was being used, and it was a very tedious job to bring up a test bench. But System Verilog is an advanced language, and which has more provision to the user to bring a test bench in very easy. And you can say like it has a more advantages compared to the Verilog, and eventually the same the advantages being leveraged to UVM, which has more advantages compared to UVM. So that's the difference basically. Verilog and system Verilog.
Okay, thank you, sir.
Hello, sir.
Yeah, yes, ma'am.
Yeah, I'm Lasya, sir.
Yeah, Lasha.
Thank you for conducting a webinar for us, and it is very helpful. But actually, I have a doubt regarding this coding.
Hmm. Yeah,
Here there are so many concepts. Like in the module 3, as you're showing, displaying this, in this
mhm,
module 3 Verilog, we are having a gate level modeling, data flow modeling, and behavioral modeling, right?
correct.
So which one is mostly used code? Because in our colleges, they are only
Mhm,
explaining about gate level and data flow modeling. When it comes to
mhm,
attending the interview or taking the exams for the internships like that, they are
mhm,
providing the questions regarding behavioral modeling.
correct.
So
Yeah.
yeah,
So the behavioral modeling is the one which gets used in most of the, because if you see the previous slides also, we were talking about the behavioral codes.
yes, sir.
So yeah, so we will be using the behavioral codes to build a design, as well as we'll be using the behavioral codes to verify our designs also in system Verilog test benches basically.
Okay.
But
So, but
yeah. Mm.
But why only behavioral? Because we are learning the data flow and as well as gate level also, right?
So when it comes to see, you tell me this maybe as you're at um, academic level. So
Hmm.
compared to these three, which one you feel comfortable?
Actually, as we learn data flow and gate level, we are comfortable with data flow and gate level modeling.
Okay. So, but all our tools and other things we have equipped, or you may say the infra what we have it is on behavioral modeling, in the sense like
Yes,
the
sir.
tools and other things. That's the
Yes, sir.
reason we are going with behavior at this
Okay.
moment.
Yeah. Thank you, sir.
Yeah. Anybody have any other question?
Hello, sir.
Yeah.
Sir, as a fresher, what kind of company will approach to get the job, sir? Verification engineer.
Sorry, as a fresher.
What kind of job to what kind of company to approach to get the job, sir?
So, as a fresher, so if you are DV trained fresher or you are only fresher, a trained
So
fresher or
only freshers, sir.
only C?
Only
Okay. So
freshers, sir.
if okay, okay, got it. So if you want to enter into a VLSI, so it is I can say there are only 2% chances out of 100 to enter into VLSI. 2%. 2%. Why I'm saying 2%? Let's say if the market is very good and there are no the trained engineers are available in the industry. It's like a hypothetical case basically. It happens maybe once in 5 year or once in 3 years. Okay, it's a hypothetical
Okay,
case.
sir.
So in such cases only, without getting trained, you can enter into VLSI. Otherwise, 98% the trained engineers only will get an opportunity to enter into VLSI.
Okay, sir.
So as a fresher, if you want to enter into VLSI, it is very difficult without
Okay, sir.
getting trained. Okay.
Okay, sir. Okay, sir.
Yeah. Thank you.
Yes,
Yeah.
sir.
Anyone else?
Sir, what
Good
is the
morning, sir.
difference between
Sorry. Please, one by one.
Hello, sir. This is Satvik.
Yeah. Satvik, please.
Sir, will AI replace the DV engineer, sir, in future?
Okay. Okay. It will see for sure. It can replace some jobs, but not the full. Okay. Why I'm saying this? Day by day, the complexity is getting increased. So, if you are bringing up tools on AI, the tool also has to be exponentially. It has to grow basically. Now we don't have tools. There are maybe the tools whatever we have very basic level, and eventually we need to grow them as well. It's a kind of baby we need to grow on the tool side, as well as by the time the complexity of the chips also getting increased. I will not say that it completely replaces the engineers, but yes, some people will get affect. Those who are not good at basically. See, it quite normal in the industry. I'll take an example. So whenever see, market is uncertain. So it could be a VLSI market or it could be any software market. It could be any market because it's these are all the private jobs, private sector jobs. So this is more volatile. So sometimes the market will be good, sometimes market will be low. So now, whenever the market goes low, who get affected? You tell me. All software engineers will get affected, or only the ones who don't have or who are not good at technical?
Who are not
Only
good at?
those can. Yes, only those candidates who are not good at technical get affected. And the ones who are good at technical, those who have learned and those who are really doing good, they will never get affected irrespective of your market volatility. Basically, it could be high or it could be low. Irrespective of any of these circumstances, the guys who are good at technical, they will never lose job and they will be always growing. I mean, they will be growing in their career always. So that will be the same case in any domain. It could be a software or it could be VLSI. Even here also the same case. So what I am going to say to you, to answer your question, once the AI is coming up, eventually today you are doing some job. Tomorrow the AI is coming up, and you should also be taking your skills to that level so that you will never be fired anytime. Okay, that happens in software also. See, day by day the technology is growing, right? So if you know the legacy technology, let's say I'm just giving an example in software. There was a mainframes. There was some mainframe jobs over there. Now also we have mainframe opportunities, but there are very less. So the candidate who are working on mainframes, if they have not upscaled to the new technology, then what happens? He will be losing the job or he will be having a less number of opportunities where he can't grow himself. So similar
Yes.
thing happens here. In even in the VLSI also you take this in design verification itself. Earlier we used to do it in Verilog, and now the system Verilog have come. Later
Yes.
the UVM has come. UVM have come. Before UVM, there were VMM was there, and after that OVM has come. After that UVM has come. Okay, so
Okay.
before UVM there were two more technologies. VMM were there, and OVM were there, and UVM have come now. So when let's say a candidate is working on VMM, he knows that OVM is coming up. Then he should look for that opportunity eventually. So then what happens? He get upscaled to OVM, and then if he's getting UVM opportunity, he get upscaled to UVM. Today we have UVM. Tomorrow we may get one more. Not tomorrow means not sooner, but it may take another 2 years or 3 years. You may get some more new methodology, but your always thought process has to be like, I mean, you should be doing upskilling every time. That has to happen. Then otherwise what happens, see, today you have learned something. After 3 years, if you're not ready to learn, then you will be losing the market. Like you will never be recognized in the market. Not after 3 years, maybe after 10 years you will not be recognized. Example, there are people, the senior people. Let's take an example of the available resources in current industry who are more than 20 plus years. So there are so many people are there in the industry now, especially in the design verification side, who are more than 20 plus years. They know only the Verilog. They don't know, or they know very less about system Verilog. They know very less about UVM. But for them, things are working because they are at a high level where they are managing the things. Those who are lesser than 20 years, they know the UVM, they know the system Verilog, they know everything, OVM, VMM, everything they know. But these guys, they don't know about it because they have some of them they know because they have upscaled themselves to know OVM, UVM, all these new methodologies, and they're good at now. But the candidates, those who don't know the new methodologies, they are struggling now, even though they have 20 years of experience in the industry now. So, what my suggestion is, today we have one technology we have. Tomorrow we will be, see, day by day, there is no doubt on the technology growth. Day by day, the technology growth will happen. So, what is the strategy we should have as an individual, as an engineer? We should upscale ourselves to the new technologies which are coming up, so then it is very easy to sustain in the market. It could be any opportunity, not only in VLSI. Clear?
Thank you.
Hello, sir.
Yeah, hi ma'am.
Sir, actually, do we have to learn any programming languages like C and Python?
Uh, C and Python. So basically, we need to know Verilog, System Verilog, and UVM. These three are the three different things we should know as a DV
Yes,
verification.
because
These
some
in
people are
Mhm.
saying there is a need of C and Python language for writing the
Okay,
code. So
okay. I'm
actually, there
coming
is,
to that.
yeah, yeah.
I'm coming to that. So when it comes to the C and Python, so where the C will be used, first of all, in our design verification. So when you are
Yeah.
doing the IP verification, you
Okay.
don't need any C here. You don't
Mm-hmm.
need any C language. When you're
Yes.
working an SOC engineer, where the processor will be there. When you talk about an SOC board, SOC will
Yes.
have a processor. So the
Okay.
processor, so you need to give the instructions to the processor because
Yeah.
in entire SOC, the head is the processor. So you need
Hmm.
to give instructions to the processor as a user. Then what
Yes.
happened? The processor will understand your instructions and it
Hmm.
start asking the peripherals which are connected or which are under processor. It start
Hmm.
instructing it what should do, what not to do, what not to do,
Hmm.
what to do, basically.
Hmm. Hmm.
So as a user, you can't go and write the assembly level codes,
Yeah.
add, store. So let's say if you want to do one job, you need to
Hmm.
write a list of assembly code. You need to write a set of the assembly code you need to write so that
Hmm.
your processor understand that assembly code.
Yes, sir.
So instead, what we'll be doing it, we will be writing small codes on C.
Okay.
Here, why I'm not very specific on why we have not added a C in our curriculum. The reason is
Hmm.
there the usage of the C is very limited.
Okay.
Very limited. We will not be using the linked list concept, structure concept. We'll not be using it. The other
Hmm.
the concepts here. We'll be using very small basic C codes. Very small basic
Okay.
C. Example, there will
Hmm.
be predefined functions. We have it in C,
Yes,
and
sir.
that will be using it. We'll be configuring a register with a value. So what you need to do, the register address you need to put over there, and the value you need to put over there. You need to
Huh.
call that function with argument. That's what you need to do there. Example I'm giving. So
Okay.
these kind of small activities will have, and these type of small C codes will use it, which
Hmm.
you can use it eventually if you know Verilog, if you know System Verilog, because in System Verilog we'll be covering the OOPS concepts as well.
Yes, sir. That is the reason I asked it.
Correct. So in C, right? So even in C, we'll be using the object concepts, pointer concepts. We'll be using it. That
Yes, sir.
anyways, it get covered in system Verilog OOPS concept. Those
Hmm.
concepts are similar basically. So you no need to explicitly go and learn C, but there
Hmm.
are things to learn. What I have discussed before, Verilog
Yeah.
system, Verilog UVM, and how you build a test bench, how you build architecture, how you write a code. See,
Yeah.
the design verification guy write three times of code. What the
Hmm.
designer do? Basically, let's say a design is of 100 lines code. The test
Hmm.
bench guy has to write 300 lines of code to automate the test bench. We
Yes,
will
sir.
be writing automated test benches. We will not write a normal test benches.
Okay.
So we will be doing automated test bench in S3. We will be doing automated test benches in the UVM. So all these things will be doing it, for which you need to write 300 lines of code of a design 100 lines of code. So that's
Hmm.
where our challenge lies. There are things which are required to learn. So that's the reason we give a low priority on learning C. Because if you know this, you can easily understand a C. You can easily write a small C codes.
Okay, sir.
So that's the reason. Now
Yeah.
coming to the Python Perl. So Python Perl, those are the supporting stuffs basically. Let's say if you want to do a regression setup. What is a regression? Regression means you will be having a list of test cases and you will be running them all together. And you will be
Yes.
pushing all the test cases to a server, a license basis. There is a lot of mechanism involved in it.
Yes,
Okay.
sir. Yes.
And
Yes.
you need some scripts, basically a small scripts where you will be you should know how to launch all the test cases on a server parallelly.
Hmm.
So
Yeah.
that is something mostly the EDA guys. So in each company, you take Intel, you take Samsung, you take Qualcomm, there is a team called EDA team.
Hmm.
Okay, or there is a tool team. We call it as a tool team basically. What they
Okay.
do basically,
Hmm.
they are working on the scripts. They are working on this the tools basically, or whatever the raw tools they will get it from Cadence or Synopsys or Mentor Graphics. On top of it, they will create some wrappers for the engineer's feasibility. So, and we will be using those scripts basically, and we'll be using it. We will not develop it because there is a specific team which is intended to do that.
Okay.
So they will be doing it. But we need to have a basic knowledge on Perl and Python because it will be helpful when you are working as a GLS engineer.
Okay,
Gate
sir.
level simulation when you are doing it. So you might need to example I'm giving. Okay, let's say when you are doing gate level simulation, you
Hmm.
may see a lakhs of warnings in your log file.
Yes, sir.
And so you are very specific of finding out one specific warning. You need to
Hmm.
know one specific warning out of lakhs of warnings you have. For that, you might need to write a small script, which is
Hmm.
on the fly you can learn and write it. It is not necessary to go and learn the Perl concept and Python concept because see, these are all the supporting things basically. Our
Okay.
our main course is the verification, and we should
Hmm.
know that that is our main course. These are all
Yeah.
the starters basically. The starters are the
Oh,
supporting stuff you can say.
okay.
So, so we don't want to basically spend more time on that because that is something which on the fly everyone can learn. Depends on the opportunity they'll get it. But
Hmm.
explicitly, there will not be an opportunity on them alone.
Hmm.
So without this main course, it is very difficult to get an opportunity. But those are all the supporting only.
Hmm.
Clear?
Yes, sir. Thank you, sir.
Okay. Yeah. Thanks. Any other
Sir,
questions? Anybody have? Yeah. Ma'am. Yes.
sir, you
Hello, sir.
told
Yes. Tell me.
sir, you told train and engineer have much more opportunity in VLSI, sir.
Correct.
What kind of training engineer you, sir? You expert?
Hey, as we discussed in our session also, so we have in
Okay.
VLSA there are different domains we have. As I said,
Yes,
design,
sir.
design verification, physical design, physical PV, lot of opportunities we have. But what our Indian statistics says from last 10 years is almost 50% opportunities on design verification. 50%
Yes,
opportunity,
sir.
approximately 50%. That's what the data I showed you in our presentation.
Yes, sir.
So design verification opportunities are more compared to any other domain.
So okay, sir. You told train and engineer only have much more opportunity differentiate as fresher, sir.
Yes, yes. So if
Sir,
anybody want to enter into VLSI without getting trained, it is very difficult to enter into VLSI.
what kind of training we get, sir?
So that is what I'm trying to explain you. The training is it is on a design side, how to build a design, how to build design, how to do a testing, design verification, how to do physical design training, physical verification training. So these are the different domains we have in VLS again. So these are the
Yes, sir.
different types of trainings we do offer. Currently, the demo is for the design verification.
Okay, sir.
Okay.
Okay, sir.
Yeah. Thank you. So anybody have
Sir,
any other
could you
Thank you,
please
questions?
sir.
tell me,
Sorry.
sir, could you please tell me how is the present VLSI market, sir?
So the present VLSA market is really good. It is doing good because as you see the statistic data. Let me quickly share the data what I have. Let me know once you're able to see my screen. Are you able to see my screen now?
Yes, sir.
So this is as and today. This is the requirements we have. Key hiring locations. So this is the current active LinkedIn data. So the in Bangalore we have 90,000 jobs, 19,000 jobs we have. And in Hyderabad 9,200, Pune 5,900, Chennai 5,700, Noida 2,700. Approximately, you see here almost like 30, almost like 40,000 jobs we have as on today. 40,000 jobs we have in the market as on today. And you know how many engineers we have? We have 25,000 engineers, almost the double of the engineer jobs we have as on today in the market. So you see here, so this is the data which I was talking about. Second, this one. See, 2000, by 2024, we have 25,000 engineers we have in VLSI, and out of which 50,000 are the DV engineers. And the current requirement, almost 40,000 jobs we have. Industry has only 25,000 engineers in VLSI across the India. This is the statistics. Any question here?
Hello, sir.
Yeah, ma'am.
Hello.
Yeah, yes.
My question is like in UVM, we have UVM sequence class, right, sir? So we have
Mhm,
also virtual sequence and sequencer concept. Like
mhm.
writing multiple sequences is equal to writing multiple test cases, or what? Or test cases are different.
So basically, that is very specific to the UVM, which can be discussed during training. No? Okay, that I mean, I don't know. Like if you have a trained fresher and you are not getting an answer, and you are trying to get the answer here, yeah, that is something which can be discussed often. Okay.
Sir, could you please
So,
discuss about the fee structure of this course, sir?
so fee structure and other things, yes, the course curriculum I've already discussed here. Fee structure and other things. Please be in touch with Taslim, and she will be the one who will be going to explain the fee structure and other things. That is a one-on-one. She will do that. Maybe you can connect offline to her. If anybody have any question, yes, you can pose the questions to me. I'm ready to answer. If not, then yeah, we can wind up the call today.
Sir, sir, I have a question.
Yeah, Shaja. Yeah,
सो
yeah.
सर
Tell me.
मेरी ना 3 मंथ्स के बाद प्लेसमेंट स्टार्ट हो रही है मेरी कॉलेज में.
Okay.
So sir, what type of entry level project I can put in my resume? Because I know Verilog very well.
Okay. So you want to enter into VLSI?
Yes, yes. Basically I live in गुजरात. मैं मेरे यहाँ पे वो इन्फोचिप्स है, फिर स्केल एज, ये सब कंपनी
Okay.
आती है. तो कौन सा प्रोजेक्ट करना चाहिए मेरे को?
So actually, like I mean, if they come over there, do they look for this the advanced training as well, or only the Verilog is enough for them?
सो बेसिकली तो आई गेस Verilog ही होता है.
Okay. So in that case, right, if If that is the case, they would be knowing it like only the very log. Any project with in-depth knowledge of it, that suffice. Any project. It could be a small project you take or easy project. Use a sequential circuit project or a combinational circuit project. You design one test bench on Verilog and you keep it over there in your resume and be strong on it. That matters a lot. So whatever you write it line by line, what you think over, what you present it, it all matters. They will never look for what kind of complex project you did it, what kind of complex combinational circuit or sequential circuit you take it. Example I'm giving. So they will never look for it. They will try to understand how much you know. They will not look for how complex your project is. That they will not look for. So any project should be fine where you can expose yourself or where you can explain the concepts in better way. Here,
Okay, thank you, sir.
yeah. So okay, guys.
Sir,
Yeah.
I have a question. My name is
Yes,
Any
please.
free tool is
Hemant, just 1 second, man. Hemant, yeah, please go ahead, Hemant.
yes, sir. So as you said, for freshers, it's very hard to get a job in VLSI industry. So
Correct.
what are companies expecting from a trained professional?
What kind of companies expectation? Basically, the placement companies you're asking.
Yes,
See,
yes, yes.
placement, yeah, as I said, right, placement companies can be, okay, there are two type of companies, or I will say three type of companies we have. Okay, not two, exactly three types. One is the fabless companies, and another one is fabless service companies and fabless product companies, and then third one is a product company. Three companies. Okay, what is the difference between these three? First of all, fabless companies. Fabless service companies means the top companies you take it as all Indian companies. TCS, you take Infosys, what is that? HCL, TechM, all these companies are the top, the service, fabless service companies. So Wipro, okay, this is also one of the companies. So these are all the top fabless companies and service companies. And the next one is the fabless product companies. Fabless product companies are the product startups. They don't have fab. Like as I said, the CMO.ai you take Protein Tech, you take a number of companies. The base out of these are basically sometimes it might be an MNC or sometimes Indian origin companies. You take one company called Ola Electric. Ola Electric is also one of the semiconductor company. Or Ola Krutrim. Ola Krutrim. Two companies actually. This is an Indian origin companies. They are the now they are in startup phase, but this is again a big company. Ola itself is a big company, but now they are at a startup phase. Now you take big companies like okay, this is a second categories of companies. What is that? The fabless product companies. It could be either of it. And third set of companies like big companies like you say Microsoft, Google, Meta, AMD, ARM, Qualcomm, Samsung. So any of this. So depends on. So first of all, depends on your how confident you are with the technical and the opportunity. Who is looking for the candidates? You may get either of these basically the opportunities. Cadence it could be, Synopsys it could be anything. Micron.
Yes, sir. So as a placement perspective, when companies take our interviews,
Mhm.
so how are they differentiating us from a fresher?
See, for a
Let's say if
normal
I
fresher,
do a
okay,
course.
okay, I'll tell you why. See, maybe I'll put out the question itself to me. The question is why the industry is expecting trained fresher, not a fresher.
Yes,
Okay,
sir.
so the answer is basically these companies, right? The big companies are small startups or Indian-based big companies. You take any of international big companies or Indian-based big companies. Any company you take it, they don't have time now. Like they don't want to spend 4 months of time or 6 months of time. See, depends on candidate to candidate, guys. Here again, say if a candidate is an intelligent guy, he can pick up in 3 to 4 months. If a candidate is, I mean, average guy, he may take 4 6 months. If a candidate is below average, he may take 10 months to cope up basically or to learn the things basically. Okay, so now the problem stands here is they don't have a training infra, inbuilt training infra they don't have, where they can add the engineers to that the training session and then they can groom. They don't have that. So that's the reason they are expecting every engineer. Okay, what they will do? Okay, let's say if you get placed, what you will go and do? So you're almost like 80-85% got trained to the corporate world, corporate stuff basically. Why I'm saying 80-85? Why I'm not saying 100%? The reason is whatever you practice, everything is like as a TV engineer, you will be you'll getting you'll get an exposure to a multiple things here. Like you take a test bench development, scoreboard development, driver development. These are different components basically in UVM. So in mailboxes, in coverage, in regression, in debugging, in coding. So you would have exposure to all these areas when you are getting trained here. But when it comes to a real world, you may get coverage opportunity. You may get the scoreboard development opportunity. You may get driver opportunity. You may get for a complex SOC, for a complex IC, for a complex IP. Got my point? So here, whatever you do, you will be doing with not the complex of the SOC, what you will be doing at real time. The complexity is lesser, the one which you will be practicing it here. But the complexity, whatever you will get it at the customer side, is a different complex. And there, you might need a dedicated person who can work on a coverage for about 6 months, example, because that coverage itself is a bigger thing there. And one engineer is required dedicated to work on that. That is something, is a small part of your design verification. So in such cases, what happens here? You got exposure to all the DV stuff when you're getting trained here, but when it goes to a client, the coverage itself is a bigger picture where you need to look at so many things in it, and then it's the concept and other things lies the same what you learn here, but applying it matters there. Applying it matters there. Example I'm giving you will be running one test cases here and you will be basically dumping out the coverage and you'll be loading and checking it here. There you have hundreds of test cases and hundreds of test cases run by 10 engineers, let's say. 10 engineers you are running the hundreds of test cases, and then they will be dumping out all the databases, and you need to know how to merge them, how to load them, and how to see the coverage, how to give analysis, and how to report it to the explicit engineers. So you need to know all this. This is something which you can learn there itself, not here. Again, that the basic concepts will never change. Basic concepts still remain same. So that's the reason I'm saying 80-85% you get trained here. 10 to 15% you will get only that customer side, depends on the project complexity. So that is that you will be learning it there. And now the industry is expecting the candidates who can come and start contributing within 15 days, within 1 month of their joining. They don't have time or they don't have a process where they can take them, they can train them, they can give all the exposure. And let me tell you, I think one person had asked in this meeting itself, e-info chip he talked about, right? One company which is coming to his placements. So I will tell you what will be the real challenge he will get it in at one point of time. Let's say in a positive note, the company has come and it got hired him. Let's say now they have hired him now. Now what happens immediately? They will not train this guy. They will not train on SVUVM concept because they will be putting him in on one project. It could be Verilog project or it could be system Verilog project. It could be UVM project. It could be anything. So immediately what happened? He will go there within 1 month. 1 month is like a stable time. Stable time in the sense like access, laptop access. It takes some time to get his normal access, laptop access, get familiar with the team member, what is happening in the project. Just basic things. Once he start, because he is also new to the industry, right? He start understanding the very basic things. Within a month, he will be deployed to a project. Now, whatever there in that project, he knows only that. He will never know coverage. Or, let's say if he has not got a chance to work on coverage, he will never know in his entire career until he go and take some system Verilog training, or he himself and study that system Verilog, understand it and apply it, he will never know in his like, entire career until he'll get opportunity, because he will never exposure, or he will never gone through a coverage, or he will never gone to an assertion, he will never gone to oops concepts at all. So in this case, now what happens? And I mean, he can sustain until he till basically he will be there in that project. If he whenever when the challenge comes, when he want to change the company, that time, let's say after 3 years, after 5 years, he is looking for new opportunity. That time he should know system very long. He should know UVM to crack the interview. Without that, he can't. And the questions also will be asked on that. So now the problem with him, even though he get placed as a fresher, the challenge for him is he will get an opportunity, he will get a job today, but where he will get an opportunity to learn the concepts, what is there on DV side, he will never get. That project will give you a limited scope. As I told, right? As when you are getting trained, you will get a complete DV exposure. But this complete DV exposure you will get throughout your career. It is not like in one project you'll get complete exposure. No, until you get a scratch IP work. The scratch IP works are 5% in the market now. The scratch IP works, there are 5%. If you get a scratch IP work, you will get the same DV exposure, whatever you get it at training level, you will get the same experience exposure at real time. So that experience actually it runs for you a long time, but the opportunities are very less in the industry. 5%, 95% opportunities are what very specific to your the training modules. Basically, it could be a small of coverage assertion. You take any other component development. You take anything. These are all very limited scope of work. You will get it there basically. Okay.
Hello, sir.
Yes, ma'am.
So sorry for troubling you. Can you please show the slides again, because I'm noting the points.
Which slide you want?
Like everything from the starting, just to revision, to make sure that I have covered all the points.
You don't worry on that. So this section is recorded, and you'll get a recording. You check with her.
Okay, sir. Thank you.
Yeah.
Hi, sir. I am Srinivas.
Yes, Srinivas, please.
So, sir, currently, like which domain has the future scope? Like whether it's a verification or physical design or analog layout, which domain has the future scope, sir?
Okay, so as per the statistics data, what I have published on these slides, right, 50% opportunities of VLSA always goes to almost 50% of opportunities always goes to design verification.
Okay. So, like, what about like analog layout domain? Whether we have any scope or not for that? If we study those kind of.
Okay, so I will not say that there will not be a scope for any of it, because see, VLSI design flow has a cycle. Okay, in cycle, digital VLSI has a cycle, analog has its own cycle. Okay, design cycle. So each project has to go through each cycle, but the number of employees who are working on a specific domain, that matters the opportunity. Okay, so let's talk about whatever the one which we discussed here. The VLSA has a different, let's say, I'm just giving a, let me show you.
Hmm.
Okay, I'm sharing my screen here. So if you see this ASIC flow, right? ASIC flow has see, at different level, there are a lot of engineers are there. Specification level, there are engineers, architect level, design level, verification level, synthesis, DFT, flow plan. Every level you have different sets of engineers are working. But the difference is you will be having a lot of engineers on a verification. That is the statistics report say. Almost like a 50% engineers working on RTL verification. So if anybody want to bring out a chip without this flow, they can't able to bring up. They have to go through this flow. But as a fresher, for you, the matters is the number of opportunities. Those are good at verification.
Okay. So is it like we can go into verification, then we can change domain, like?
I will not recommend to do that. The reason is, okay. See, if you have chosen an electronics engineer, let's say I'm giving an example. You have chosen your BTech stream. So, do you think that changing a domain after 4 years will it really help you?
No, like,
Hey,
but you are saying like the opportunities are limited for certain domain, so for freshers. So
Mhm.
if I want to go into that particular domain means, so what can I do?
So here there are two things. Okay, let's take an example of it. Before you join BTech, either you take a decision. What decision? Example I'm giving. So anyone, if anybody want to join a BTech, they should take a decision which stream they want to be. Once they entered into, and they should be good at that. They should be
Mm,
good at that. Let's say I'm studying electronic engineer. I don't know for what reason I have opted the electronics. It could be by force, or it could be someone on the roadside who is going and say that, oh man, there are opportunities to go and take the electronics. Okay, by whatever the reason, I have chosen electronic. I have come in. When I'm coming in, when I came in, my objective is now how I should become best in electronics. How I
okay.
should become best. So as I said you, there are analog layout opportunities. I'm not denying that. There are opportunities, but there are less opportunities. It doesn't mean that I'm asking you to come out of it and take the other domain. No. You be good at analog layout.
Mm,
You be strong at analog layout. Irrespective of the market condition, you should learn the concept in such a way you can sustain in in every tough situation. You can do best now. You can do best in analog layout. Why do you want to
mm,
change?
So
Don't do
wherever
that.
we go, so if we know
Yes.
the concepts and those kind of basics,
Yes.
then we can survive.
Yes. Yes. So I will not recommend to change one domain to another domain. But my suggestion is do best wherever you are.
Okay. Okay, sir. So what about the PD? Like whether opportunities are there or like compared to verification?
Hey, the opportunities will be there. Okay, that is where I have showed you my data. So this is the data. If you look at this data, just look at this data. In 24, 25,000 engineers were there. In that, 11,000 engineers of the TV engineers. The PD engineers are there. I'm not saying that the rest could be a PD, rest could be the DFT, rest could be analog. There might be engineers. But I have my interest is to say almost 50% engineers are from DV.
Mm,
This is the basically the year-on-year data.
okay. Okay,
Excuse me,
sir.
sir.
Yes, ma'am.
I have a query about the internship
Mhm.
purpose. Which type of skills does company required for that?
Internship purpose. So yeah, you might need to approach it. Depends on your profile and the type of. Maybe they might look at your academic, or they might look at your communication. They might look at your interest, basically, to offer the internship. As such, they will not look for a specific profile because when you are a graduate, right? What kind of thing you will be having it like common to everyone, right? There will not be. I mean, you can't bring up your explicit profile, which can attract anyone. But these are the ones usually anyone can look at to offer internship.
Which skills are required to do internship in
Like
VLSI domain?
as I told you, right? Like I mean, your communication matters, your academic record matters, your interest matters. All these are the three skills can be looked at to offer that. And again, the opportunity has to be there from the client side.
Thank you, sir.
Sir,
Yeah.
sir, any free tool available in practical system very lab, sir?
Any free tool is available, so I cannot comment on that. Sorry for that.
Okay, sir.
Yes, guys, thank you so much for the session.